Hi everyone, and welcome to my channel. In today's video I'll be talking about subnetting. Let's say we have this IP address 192.168.1.54 and we're asked to find the network address, right? We're asked to find broadcast address and usable host range. So how do we go about that? Now, let me just quickly explain what a subnet mask is. A subnet mask is um, um, a subnet mask separates an IP address into two portions. The first portion is the network portion which identifies the network, and the second portion is the host portion which identifies the device. When we talk about the host portion, we are talking about the uh, devices that are connected within a network, and it could be printer, it could be your phone, it could be your computer, whatever. It could even be a router, right? So these are two portions in which a subnet mask is divided into. Now let's use this example. Like I mentioned earlier, we have an IP address of 192.168.1.54/28. Now the subnet mask of this IP address would be 255.255.255.240/28. I'm going to explain how we came about the 255. Let's continue with the video. Now, this means that 192.168.1 is network path, while the last octet, the 54, is the subnet and host calculation. So what does /28 mean in this network address? IPv4 has 32 bits, right, which is divided into 4 octets, and 4 octets includes um, 8 bits of ones and zeros, ones or zeros. So how did we get this? Let's just pay attention to this. So we have 4 octets, 1, 2, 3, 4. And again, I said each octet has 8 bits. So because we have 8 bits of ones, that's why we could have 255, 255, 255, 255. In case whereby we have 8 bits of ones and zeros, it's not going to be up to 255. I will explain further. How did we get the 255? Each bit of 1 has a place value. For example, we have 1, 1, 1, 1, 1, 1 in 8 places. So we have 8 bits of ones. And the place value of each 1 bit is from 128, 64, 32, 16, 8, 4, 2, and 1. So when you add up these place values, you're going to get 255. So that's how we got to the 255. And that is how we got the 255. That is the subnet mask here. Okay, so remember that our subnet mask here is 255, 255, 255 dot 240. So the last octet is not up to 255. So that's what we are trying to explain here. So if the prefix is /28, it means 32. Okay, I actually omitted something here. So I'm saying that each bit of 1 has a place value, and we have this 8 bits of ones, and the place values are written above here. So 255 is the sum of the place value of all these bits in an octet. So if the prefix is /28, it means 32 minus 28 will give us 4 host bits, and that's what we are looking for. So the subnet mask will be 4 octets, okay, and each octet has 8 bits. So focus on the first 3 octets. In the first 3 octets, we have 8 bits of ones, but in the last octet, we have 4 bits of ones and 4 bits of zeros. So that is why we could not have up to 255 as the sum of the place value. Okay, so let us just calculate how we got 240. Okay, so since we have 4 bits of ones and 4 bits of zeros, so we are calculating the place values of the ones and zeros, and that's what is going to sum up to 240. So the first 1 bit is 128, the second one is 64 plus 32 plus 6, and so 0 actually has no place value. So we just arrive at 240. Adding up 128 plus 64 plus 32 plus 16 will give us a sum of 240. And that is the sum of the place value of bits of ones in the last octet. I hope we got this. Again, to convert /28 to mask, we'll have 255.255.255.240. Remember, we got the 240, the sum of the place value of the last octet. And in the last octet, we have 4 bits of ones and 4 bits of zeros. Remember, IPv4 has 32 bits of ones or 4 octets. Each octet has 8 bits of ones as illustrated above. So we have 4 octets. The first 3 octets have the first 3 octets have 8 bits of ones, while the last octet has 4 bits of ones and 4 bits of zeros. So that's how we got this. So we have 8 plus 8 plus 8 plus 4. So did you now see how we got the 4? So the first octet has complete 8 bits of ones, same as the second bit and the second octet, same as the third octet, but the fourth octet has 4 bits of ones and 4 bits of zeros. So we are calculating 8 plus 8 plus 8 plus 8 plus 4 because we only have 4 bits of ones in the last octet. And so 8 plus 8 plus 8 plus 4 gives us 28. That's how we got the /28. You can just replay this video to understand what I'm trying to explain here. So I'm trying to explain how we have or come about the /28 in our IP address that is given us, right? So we come about the 28 by adding the number of bit of ones that we have in the IP address given to us. Okay, that's how we got /28. In other words, this means that out of 32 bits, 28 bits are reserved for network portion, while the remaining 4 bits are left for the host addresses, because 32 minus 28 will give us 4. So those 4 host bits determine how many IP addresses exist in each subnet. So using the formula 2 to the power of n being the number of hosts, so we have 2 raised to power 4, which is 2 times 2 times 2 times 2 equals 6. So we have each 28 subnet contains 16 IP addresses. So out of the 16 total addresses, the first address identifies the subnet itself, which is the network ID. Remember I said that the subnet mask has 2 portions. The first portion goes for the network address and the second portion goes for the host address, that is the end device's address. All right, so the last address is reserved for broadcast traffic, and the remaining 14 addresses are assignable to hosts. This gives us a block size of 16, and that means subnet boundaries occur every 16 addresses. So we have the ranges from 0 to 15, 16 to 31, 32 to 47, 48 to 63, and up to 240 to 255. So we have 192.168.1.5/28. So in these IP addresses, which is giving us 54 is between block 48 and 63, just as we can see it here. Where is 54? Where can we find 64 in this address range? 54, right? So it should be between 48 and 63. Network address therefore is 92.168.1.48. Now, how did we get the network address? We get the network address from the range that we have here, which is 48, between 48 to 63. So remember that the network address we say is the address of the network, okay, that is hosting the devices that are connected to each other. And then the broadcast address is 192.168.1.63. So the usable host range is everything between network address and broadcast, which we have the following: 192.168.1.49 all through 192.168.1.64, and we have number of usable hosts is 14. um, is 14. So that is to say that we have 14 number of usable hosts that have their unique addresses within this range. All right, so if you understand what I'm saying here, leave me a comment in the comment section. Also leave a like and subscribe to the channel. And again, if you do not understand, just drop your concern or your questions. I will address it. Thank you, and see you in the next video.